2, and 3. I'll do 4.
I'll do 5.
Yeah.
So you do 1 and 4. I'll do the other 3.
Okay.
Okay.
So to start off with, we have problem 1. So we have our cross, our inversion cross. And to get this inversion cross, to get your products, you have to, your first product is just going to be your normal chromosome, which is going to be your normal and healthy chromosome, as you see there. Your second one is going to be your inversion chromosome, so it's going to be inverted but still healthy. Your third one, you're going to take your ST, and your inversion is going to be all recessive. So your ST is going to go right there, and then you start off from your S and go backwards from your inversion. So you're going to go S, R, W, X. That's the first part. X, W, R, S. And then you complete it with your your leftovers. So you've got U, V, P, Q, O. I hate reading this backwards. For your third one, that's a little bit more tricky. You start off with your first chromosome, and you go LMN, which you see down here, LMN, O, P, Q, R, S. But because your S is where your inversion is, you go down to your, hold on, I can't read it backwards.
You flip back over to your inversion, I want to say.
You switch over to your inversion, so you go LMN, OP, QRS. You go to your recessive, TUV, QPO, NML. And you have 2 centromeres on that one. And it's dicentric because it has 2 centromeres, and it's unhealthy. Your last one, you're going to take your, you're going to go backwards from your first normal chromosome, XWVUT, and then you do the same thing. You go down, you go SRWX, and that is your fourth, and that's acentric and unhealthy, so it doesn't have any centromeres.
For the second one, non-disjunction and meiosis 2 produces 50% gametes, whereas non-disjunction and mitosis produces mosaic phenotype. For the second part of it, meiosis is an individual who has suffered a paracentric inversion. For the third part, it's the Turner syndrome is the first one by monosomy, while familial Down syndrome is an example of disease caused by Robert-Sarian translocation. The human liver cells can be 4N, 8N, or 16N. For the next one, you have a terminal deletion in chromosome 5 causes Kreudig-Chatt syndrome, while an inversion on the X chromosome causes type A hemophilia. A duplication is a change in chromosome structures that could possibly be beneficial depending on what happens there. And then a translocation cross has formed the alternate segregation pattern produces viable gametes and offspring. Again, there's the answer on that one. For the next set, so for the first section of question 3, for Turner syndrome, there will be 45. There's 1 less chromosome in Turner syndrome there. For Jacob syndrome, it's the opposite. There's 1 extra chromosome than the 46, so you end up with 47 there. For Kreudig-Chatt, familial Down, and type A hemophilia, there isn't actually a change in the number of chromosomes, so they're all going to be 46, just normal. For the second part with Charcot-Marie-Tooth disease, we know that it is diploid, and we also know that it's caused by a duplication. But where it's asking that it's not associated with it, everything except for those 2 are what's not associated here in this case. The next one for Klinefelter's disease, it's what is associated. And then aneuploid is the first one there because it's also going to be trisomy. So it's an odd number of chromosomes there, and it's caused by non-disjunction of the sex chromosomes. And then for type A, hemophilia, it's only deletion is the only one that's correct there because it's caused by an inversion actually there.
So number 4 was the trickiest one out of all of them. Actually, I had to ask the teacher about this one. So for the first part, you have to set up a diagram, something close to this. Your first, it has it written down your first 2 homologous chromosomes, and those are going to be found right here and right here, your top and your bottom. And then these are going to be your 2 other sets after the translocation occurs. So the next 2 chromosomes that it lists are your translocation ones. For B, you're going to take the diagonals. So you're going to do your first homologous chromosome with your second homologous chromosome, and then you're going to take your translocated chromosomes and put those together in a cell, and you're going to get duplicates of both of those. So you're going to get 4 cells with one with a duplication of the homologous chromosomes and the other one with the translocated chromosomes. C is your adjacent one. C, you're going to take your homologous chromosome, number 1, and you're going to do it with your translocated chromosome, number 1. And you're going to do the same thing with the other homologous chromosome, number 2, with your translocated homologous chromosome, number 2. And you're going to put those in 2 different cells, and they're going to be duplicated as well. So you're going to get 4 cells. Adjacent to, you're going to take your homologous chromosome, number 2, and put it with your your translocated chromosome number 1. You take your homologous chromosome number 1 and put it with your translocated chromosome number 2, and you duplicate those, and you get 4 cells as well.
And for the last one, with cats being 38 chromosomes, you know that N equals 19. Therefore, a triploid cat would be 19 times 3, which is 57. A cat that is monosomic for chromosome number 12 means that there's going to be 1 less than normal, so it's 37. The cat that suffered a terminal deletion of chromosome number 7 means that it still has a chromosome there, so there's 38 chromosomes still. A cat that suffered a Robertsonian translocation between the 2 means that they lose 1 chromosome, so they go down to 37 as well. And then the last one, reciprocal translocation, means that they just switch places, so they keep with 38 chromosomes.
Yep. Let's do a little run through the answers real quick so you guys see them. You guys can rewind it if you guys need
So
to.
desire.
Yeah. There we go. This one's just deletion. That's how we set it up. And there are the answers. And number 5. Thanks for watching.